So in this one we will do another one of our strength of material problems. So let's just read. 3 rods are made of different material and attached and loaded as shown in this picture. Calculate the safe value for P, that's our interest, such that the stress does not exceed this number of 120 MPAs. And so each and every part or section of this system has its own different material, so it has different yielding stresses. So let's try to find the suitable P. So let me start finding the steel. Yeah, that's cool. Let me find something that I can call force in the steel. Force in the steel. I'm just going to cut here and look all the forces that are that side. I think my thing is too thin now. Yeah, it's just not, doesn't look good. I think that's fine. Force in the steel. A little too big. Force in the steel, that's fine. Then we cut here. After cutting here, not really cutting literally, I'm just looking everything that is on this end. That is on this end. Okay, so if you notice, we have a force going this way. We have a P going this way. We have a 2P going this way. 2, 1, and 4. So literally, if I say this side is positive, this is going to be 4 minus 1 plus 2. So that's going to be my force that's experienced by a steel section. So here it's going to be 6, right? Is it? No, it was going to be 5. Okay, and then P's. These forces are in terms of P, right? Let's look at something else. Let's look at forces on aluminium. So I'm going to do literally the same thing. Forces on aluminium is going to equal to, if I cut here, now I'll look at all the forces that are this side. So what do I have this side? I have a P going this way, a 1. I have a 2 going this way. So that means I'll end up having a 1 going this way. So that is going to be 1 compression. And what was happening here, I also think it was compression. Okay, this is 1 P, so let me just say P. So then I move to the next section. I cut here, right, and the only force that I see from my right end is only 2P. So on force on bronze, it's going to be 2P. Okay, so it's also on the compression. Okay, so this is a compression. It should have been tension, it would have had T, but didn't have it. Okay, then what else? We know that stress is equals to force. Stress is equals to force all over area. Yes, this is stresses. Oh, we are also given areas. Oh, surprised where the areas. Oh, now we're also given areas, so it's nice. So we're looking for steel, right? Steel has its own given to be 140 MPa is equals to the force on steel is 5P all over the area there. It's given so nice as 500 mm squared. Then you know mm's and these ones, they cancel so nice. Then we'll end up having P is equals to 140 by 500 all over 5. So I think that will be our first P1 or P max on the steel. So after calculating, I'm getting 14 kN. Okay, and then let's move to the next one. The next one is what is aluminium. So stress on aluminium is going to equal to force on aluminium is P all over area on aluminium is 400, and then our stress, the max that we could take was 90. Then our P is going to be 400 by 90. Then P is going to equal to, and then for this one we're getting 36 kNs. So that's really huge, almost double of that one. Okay, then let's look at stress at bronze, right? It's equal to force at bronze. What is force at bronze? I think we got 2p, I said pp's 2p or area, and our area there was 200. I don't write units because they just cancel each other very well. And then our max stress there was 100, so at 100, and then P become P become, what is it, 100 by 200 all over 2. Then my P becomes, then here I'm getting 10 kNs. So what was the question again? Saved value. So saved value is actually the smallest, so that none of these things actually fail. So which one is the smallest? We have 10. Obviously it's going to be 10 kN is the mean. Okay, thank you. That's all.